Hello everyone, today we're going to introduce our project, Deep Learning Approaches to Antibiotic Classification. So antibiotics are great. They are the cornerstone of modern medicine, but they're not great forever, as the resistance quickly build up. However, the discovery process is getting slower and slower. The data shows that without immediate action to find new antibiotic, deaths related to resistant infection will reach 10 million per year by 2050. And one potential solution is deep learning. Given a molecular graph structure, we want to use deep learning approaches to predict if it is an antibiotic or not.
We want to compare two approaches to antibiotic classification. One is fingerprint vector model, where we re-implemented fingerprinting and implemented 4 models from scratch. The second is simple graph convolutional network. We modified SGC model from literature and incorporated model ensemble and hybrid model. We have 2,335 molecules for training and 162 molecules for testing. Each molecule is labeled as active or inactive antibiotic. SMILES is string representation of molecular structure. Through fingerprinting, we extract features and hash them into bit vectors. In fingerprint vector approach, we use molecular features, but in SGC approach, we use atom-level features. We know that more than 95% of data belong to inactive classes, and we deal with imbalanced data with our SGC approach.
Well, in our fingerprint vector approach, we implemented 4 different approaches, and 2 of them are traditional machine learning approaches, the linear perceptron and the support vector machine. And the 2 others are deep learning approaches. For our multi-layer perceptron model, we have 4 linear layers, a read layer, and batchroom layers.
Our time delay neural network consists of 4 1D convolutional layers, each followed by ReLU and finally a linear layer. We tested 2 versions, one with padding and one without.
SGC model is a graphic model which has B as a set of vertices or atoms and A as an adjacency matrix. Aij denotes the boundary between vertex I and vertex J, and D denotes the degree matrix, and Xi denotes the feature of each vertex I. X is a feature of the whole graph or the whole molecule, which is a concatenation across all atom features. So given a whole graph as an input, we are doing basically 2 steps. The first step is called feature propagation, where each atom learns the feature of its neighbors by taking the weighted average. Then we do the feature transformation by using learnable weights and do not apply any nonlinear transformation since we assume nonlinearity. Finally, we make prediction by taking the sum of features of all atoms and apply softmax.
2 new approaches we add to the SGC method are ensemble and hybrid model. So in ensemble, we split origin data into different subsets and train individual model on them. And during the final prediction, we make those models vote to do the prediction. And in hybrid model, based on the SGC model using the atom feature, we add the molecular feature at the final linear layer and I hope that can help with the classification.
In our result for our fingerprinting vector models, we can see that the MLP classifier has the best accuracy on the testing set with an accuracy of 85.8%. However, the TDM model has the worst performance among the 5 models.
Here's a result for SGC network. Although there's a high training accuracy and a validation accuracy in the SGC model, it is because the imbalancing data. So the model simply treats the popular label as the predicted label. And as you can see, in a testing, when there's a more balanced mixture of label, it has a worse performance. And in the SGC model with ensemble and a molecular feature, the amount of split data feed into the network is not enough to let the model to learn the data. As you can see, the result is barely better than a random guess. So here's our conclusion. If we look at the number, the MLP classifier is a better method to do the antibiotic classification. However, there's a paradox in SGC. Its linearity gives us the potential to interpret inside the black box. So given a weight matrix, we can see which feature is heavily weighted, and we can trace back to see what function or what molecular feature is that. However, the linearity caused the model to not learn the data as well as MLP.